Okay, so today we're pretty much talking firstly about iteration 3, just like we did with the other lecture. We will be talking about the spec, what's changed, just a little bit of an overview, just to give you all a bit more comfort, and then we will be talking about a few more specific details to do with this iteration, such as stand-ups and storing static files and emails. Though we won't be talking about those in a great deal of depth. Where we're going to start today, though, is the actual project spec and what's changed. What's really useful about this iteration is that because it is iteration 3, or your third iteration, you're pretty comfortable with these changes by now, which gives me a lot of comfort that you can figure a lot out yourself, but let's still actually have a look through it together. So this has been rolled out to your repositories. I believe we pushed it out the Sunday night of week 7, just before week my hair just before week 8. And let's just go through like we normally do. Iterations 0, 1 and 2 are all done and complete. Yay, good job. I know that for many groups iteration 2 maybe didn't exactly go how you'd want. That's okay. It's somewhat normal to have that one be a little bit difficult. We were talking a lot with the tutors about this term. We noticed that a lot of students struggled with this iteration more so than normal, which was quite interesting for us because we hadn't really changed it, if that makes sense. But we have a few theories, but one of the main theories we have that we've noticed a lot, or at least your tutors noticed a lot, was that in previous terms, we actually used to have these things due earlier. We actually used to have it due, for instance, on the Monday of week 7 was like a really common thing. And then iteration 3 would be due on the Monday of week 10. But this time I've tried my best to give everyone more time. So iteration 2 is actually due at the end of week 7. And iteration 3 is due at the end of week 10. And what we noticed just from talking to a lot of groups, at least this is what tutors passed on, was that because the project for us was due at the end of week 7, a lot of students and a lot of other courses had a lot of assessments due at the start of week 7 from other courses. And naturally, if you're a student and you've got, like 1 or 2 assignments due at the start of week 7, you're going to go and do those. And I think that's the right thing to do. The advice I always give students is always do the thing that's due the soonest. Like, just always focus on that. So we definitely noticed a lot of groups and students who kind of seem to get iteration to get their other courses work done at the beginning of week 7, and then they kind of start properly on iteration 2 on like Monday, Tuesday of week 7. And obviously that was just very tough for a lot of groups. We also noticed that some other groups, there's been a lot of people out sick. It's winter, it's COVID. There are other people who are just kind of exhausted. We noticed this we just noticed this more and more. This happened in T1 too. People are just kind of fatigued from 2021 still. So, when they get flex weeks and stuff, they're just going to sleep and relax. And what was the other thing we kind of talked about? There was a few other things we talked about in terms of changing some lab exercises around to kind of force students to learn some things quicker. But broadly speaking, all I wanted to really just talk about was that there are lots of reasons why students struggle with iteration 2. You're not alone. Many students struggled. I don't have average marks or anything for you. I could probably look them up. I could probably even look them up now really quickly just while we're talking. But it's just kind of like stuff happens, and sometimes things go right, sometimes things go wrong. Every week of my life something happens that I'm not happy with and I wish didn't happen, and you just pick up and keep going. I'm just having a look at the current average auto mark. So the average auto mark for iteration 2 looks like it was about 27%. It's not 27%, sorry, 27 out of 50. It's like about just over 50%. Jesus. It's just over half, and the rest of the marking will go in this week. But the point I just wanted to get at there was that just don't beat yourself up for anyone who's feeling crummy about it. I have a very straightforward philosophy on everything with life broadly, which is that, every single day you have more things you want to do well at than you do. You want to eat well, you want to study well, you want to work well, you want to be a good child, you want to be a good parent. Some of you, maybe you want to be a good sibling, you want to be a good partner, you want to be a good friend. You want to learn, you always want to do all these things, and at the end of the day, you just can't do them all, and you make choices. Sometimes you focus on your mental health. Sometimes staying in bed and watching TikTok for that moment in your life is actually the healthiest thing for you. So don't beat yourself up if you live with intention, is my point. If you just were doing other things and you were at the limitations of what you can do, and you had 20 things to do and you could only do 10 and you chose the 10 that mattered, and 1531 was not in that 10, or that's not that binary, but if that's what you did, then great, be proud of yourself. You didn't get everything you want, but none of us do all the time. We can just pick and choose what matters to us at any given day and week. So move on, keep going, keep doing better. Whether you did well or whether you didn't do well, you forget about it in a couple of years. That's what matters. So let's look at iteration 3. So iteration 3 is really building off the work you've completed in iteration 2. If you haven't finished parts of iteration 2, that's okay, because implicitly some of the marks we give you for iteration 3 are actually testing things in iteration 2. So it's not like you have to do this work for free, because if you don't do it for iteration 3, you still don't get even more marks. So if there's still some things in iteration 2, you will need to kind of finish them off. Now, having a look through this, 5.1, the task. The first thing is to make adjustments to your existing code and tests as per any feedback given by your tutor. That makes a lot of sense. So if they give you feedback either last week in week 7 or this week in week 8, then make sure you actually go and implement that. Number 2 is to implement a server and test it. And most of this is very, very similar. Most of this is write some tests, write a server, we will auto mark it, persistence, ESLint, everything like this. A new thing added here is coverage. We talked about coverage on Tuesday of week 7, or last week, and we will be marking that in this particular iteration. So that's one thing. Let me take some notes for you, just so you can kind of keep your own mental map of this. I'm just taking some notes of some new things in this iteration. So we got coverage. Everything else is pretty much the same. Continue demonstrating effective project management and Git usage. Okay. You'll work effectively. Task tracking and management. GitLab board. All of these things are relatively straightforward. Document the planning of new features. This is a new thing. This is what I would call a non-technical thing. So we got technical stuff, which might be coverage, and then non-technical, which is document and planning, which we have to read more about. And then number 5 is to deploy your backend, right? To deploy your backend to the cloud. Now, thankfully, you've gone and done this in iteration 2, right? Sorry, no. You've gone and done this for your lab, for lab 5. So I'm going to call this one non-technical, because to be honest with you, it's kind of both. It doesn't really matter. It's not a lot of heavy programming problem solving. It's just a lot of fiddling. So that deployment part is kind of relevant. Jack's asked a question, which is, are there any reasons why the front end wasn't working for iteration 2? Now, occasionally the front end doesn't work. Very occasionally it doesn't work because someone on our team made a mistake. Very occasionally it doesn't work because no one made a mistake. It just so happens that you did something in a weird way that we weren't expecting, and it's all perfectly fine. The majority of the time, what goes wrong is that what we write, the front end is compliant with the spec, but your tests and even our auto markers might miss things sometimes. So the short answer is you probably have to post on the forum, but generally speaking, if you pass your tests, this is not to you, Jack, specifically. If you pass your test, but it doesn't work with the front end, there's a good chance it's because your tests are wrong, and therefore your implementation is right based on those wrong tests, which makes your implementation wrong, which is what's causing things to break. If we go to 5.2, running the server. So to run the server, you can run the following command from the root directory, npm start. This is all exactly the same as iteration 2. Implementing and testing features. You've seen this for a long time. It's exactly the same. 5.4 is a new section on test coverage. So we talked back in week 7 about getting the coverage for your code, right? As in, you can run your server and run your tests, and you can see what the code coverage of running those tests is. And you can see here that if you would like to do this for this iteration, you actually just have to run these two commands, which is npm run ts node coverage and then npm run test. Now, npm run ts node coverage is just the starting of the server, except instead of running npm start, you run npm ts node coverage. It is the same as running your server with TS node. It's just that it also has this extra layer that is needed based on the way coverage works. So testing is identical in this iteration, except you should just run the TS node coverage part instead of just, npm start, because that will allow you to do it. So that's one of the new parts. Dry run. I believe it looks like our tutors have gotten a typo. Oh, actually, no. So I don't think this is a typo. This always confuses me every term. But I will triple check for you. If it's a typo, we'll change it. But typically, the thing is that for iteration 3, we actually have the exact same dry runs. And that's because for iteration 3, while we do get you to do some more routes, it's still like the basics are still the same. So the dry runs are just there to make sure your code isn't fundamentally broken. And checking your code not being fundamentally broken is the same for iteration 2 and iteration 3. Okay, 5.6 is somewhat interesting. 5.6, what I'd say is that we should probably come back to this at the end of the week. But basically, a part of iteration 3 is for your team to actually do a little bit of documentation and planning. It's not that reliant on the lectures because this is actually pretty easy overall, but it will make a bit more sense if we talk in the lectures first. So we can come back to this after we go through the rest of the lectures this week. But essentially that section there is a bit of document writing. So, requirements and design work that requires just a little bit of documenting. Like, writing a report, basically a Google Doc together. There's a section on deployment, which I'm going to skip over because it was kind of touched a bit in the lab. And therefore you should be at least half familiar with that topic. And then when we get to the marking criteria, what we can see here is that 55% comes from auto marking. So a lot, I think even more than the previous iterations. You can see that some of the marks this time don't just come from the implementation and tests and stuff, but they actually also come from your code coverage based on Jest coverage. 10% of the mark comes from code quality. That's less than normal, so we're reducing that amount down. 10% comes from Git and project management, which is also 10%. We've reduced that down. And then there's a couple of new sections here, a few new sections that are interesting. The first one is feature demonstrations. So for this particular iteration, your deployment, the deployment of your app, the implementation of 2 routes, which we'll talk about later, which are upload photo and password reset, are a little, and working with the front end are a little bit harder to kind of auto mark. So we actually just get your tutors to mark these manually. So 10% of your mark actually just comes from these things here. So think of that like, part of your auto marking. It's like doing stuff. It's like your implementation that we're marking. And then we've got 2 new ones down here, one being a requirement and design for future work, which is that documenting planning thing I've mentioned, where we're going to ask, we have asked you to, the summary of it is that we want you to try and figure out some requirements for the new iteration, as in like go and learn some things from some users and then plan some future work and document that up together. And then this last 10%, which is quite interesting too, is the bonus marks. So for iteration 3, there's actually an extra 10% of marks on top of the 100% that we give you which you can get as bonus marks. And these can be done by essentially adding extra features, particularly to the back end. So this isn't, whilst groups can go and modify the front end if they want to, you all kind of just don't have the experience, I guess, to modify it in most cases. So most of the kind of bonus features that we're talking about are typically things that you can do by modifying the back end. And we have some examples. So one of the easy things to do is don't change the interface, don't change the front end, but change what some of the interfaces do. I'll give you a really simple example of a cool bonus feature someone did once, which was, this is like a more user-facing bonus feature, which was they went and kind of like Slack and Discord and stuff, they went and added like a slash command. So if you typed in like /weather and sent that message as if you were sending it to your team, it would actually then, after it's sent, it would return to you what the current weather is where you lived. So you type in weather, and then the server would use some like, geolocation service on the internet to figure out, like based on your IP, like where you probably live, and then to get the weather at that point, and then just add that to the list of messages. Other groups would do stuff a little less obvious, like they would go and restructure all their code to use a real SQL database or some object-oriented approach or something. But usually I think the coolest things to do for bonus marks are probably those ones like the weather thing. There was an example. Now, what's really important to emphasize with these bonus marks, because this can get lost really, really easily, is that it's really tempting to kind of go out there and just completely look at all these marks and think, yes, I'm going to work really hard on some bonusy thing. But what I always tell students is that the bonus marks are the hardest marks to get in this iteration. Okay? And what we mean by that is like per hour of work, the bonus marks will give you the least marks. So don't ever start here. In fact, stay away from the bonus marks until you feel like you're pretty well nailing all the other areas. So until you feel like, your team has done all the implementations and done the documentation, then move on to the bonus marks. This isn't here for groups to like choose to do some different work. This is for groups who are getting close to 100%, who want to actually, push beyond that. There's always the question every term, which is, what do I need to do to get full marks? And it's a really hard question to answer, because how do you quantify what's worth it or not? What we do with tutors is that when groups actually have bonus activities, we share them around the tutor body and we all kind of mark them together so that everything's fair. But the example that I add to the spec, just to give your brains a little bit of comfort and clarity, is that typically a group scoring that 10%, or in the top 10% of bonus mark. To get full marks, we're expecting that a group who is like one of the higher achieving groups spends about 40 hours on this across the team. So if you're a group of 4, and these are all just estimates, don't come and reverse engineer the numbers or anything. If you're a group of 4, what that means is that we expect that if you're a higher performing group, that to get full marks and bonus marks, you're probably going to do something that requires 3 hours each of your time for the next few weeks. Now, before you say again that, wow, that sounds like a lot, it is. That's why it's a bonus mark, So we don't expect people to do it. It's there because it's fun, and I like giving people room to grow and to try things out. So most of you will just look at that and think, not my cake. And I think from my rough count in previous terms, maybe 2/3 to 3/4 of groups, maybe 3/4 of groups just ignored that part. And I think that's the right thing for a lot of groups. Now, if we come down to the auto marking component here, there's a very interesting formula. And this formula says the auto marking formula is basically 95 times something complicated. But if we break this up, it's actually quite straightforward, which is that 5% of your mark comes from your ESLint score. 95% of your mark comes from this thing. What this thing is it's basically your tests against your code, which should all be 100%, because you all have the ability, no matter how deep into this project you are, how smart you think you are, you can definitely write tests and write code past each other. You can do that when you submit. There's no mystery there. So that T should be 100%, and most of you get 100% in that anyway. The second one is I, which is essentially the auto marks as you understand them, which is we run our tests against your code and we give you a mark. That one you're very familiar with. But a new one that's been introduced here is C, and C is the coverage score that you get. It is statement coverage or line coverage, as we've seen, and we looked at this in the last lecture where we typically had 87% or 66% like line or statement coverage. I think it will be statement coverage, but essentially what we do there is that it's a little bit complicated. I don't want to go into too much depth with it, but the best way I can explain it to you simply is that the thing about coverage is that a good group scores 100% coverage. An average group probably scores 96% coverage, and a bad group scores 88% coverage, say. These are just numbers. It's very easy to get relatively high coverage scores. Now, normally, when it would come to giving marks to students, you might do what's called normalizing marks, where what you do is that you actually look at the highest and the lowest, and the person who gets 88%, maybe you give them 0. The person who gets 96, you figure out that 96 is, maybe 60% of the way to 100, and then, you spread out the marks across a, top to bottom. So if the bottom mark's 88 and the top mark's 100, you spread them out. Now, I'm not a fan of that approach that much because I think that it puts your performance somewhat based on how other people performed. There's 100 ways you can do it, but the approach that has been taken here instead is to actually cube the mark, which I know sounds like very complex, but it's not really. It's quite simple, right? Like if you take, and you can see this by typing in Google, it's like if you take a percentage like 0.99 and you cube it, you get 0.97. And if you take something like 0.97 and cube it, you get 0.91. And if you take 0.96, you get 0.88. And if you take, say, 0.88 as in 88%, you get 0.68. So what it essentially is it's a marking scheme designed to not aggressively punish, but also like lightly slap for lower coverage, because 90% coverage is not great, is the point. You can all easily get 90%. So therefore, if you do get 90%, that C score you get will be about 73% of like mark. So your coverage, we cube that to get your mark, right? It's very crude. We probably should have that be a bit more aggressive than it is, but we like you all. We think you're all lovely people. And then there's this weird min C plus 100 here. So if you imagine this as C, it makes sense. Coverage cubed. But the reason we got all this min stuff here is because we also understand that 100% coverage can be really tough for groups. You get diminishing returns on some things, as in some things you can spend hours on trying to get that last 1%, but just the way the code's designed, or some things just are literally impossible to test coverage to get test coverage on. So what we basically say is that we will give you all 1 mark. So if you get 99% coverage, we'll mark you as if that's 100% coverage. If you get 97% coverage, we'll mark you as if that's 98. So essentially all you really need to do to get 100% is to get 99% at least. So that's the breakdown of those marks there. Now, extra features, you can go read through this in your own time, but here are some examples of things that people have done before. As I said, we don't expect you to modify the front end. The hangman is a good example because you don't actually need to modify that front end. So, yep. Peer assessment as normal. Interface, which we'll talk about now, which is one of the last things. So Alex has asked a question. Alex's question is back on the coverage stuff. Is it possible to get more than 100% if you do bonus marks, or is it capped at 100? So you can get more than 100% at iteration 3, and it does bleed into the previous iterations, but not beyond that. So basically, the short answer is that you can use it to like top up marks into other iterations, but not beyond that. So like if your group has 100% in all the iterations so far, which no one does, I don't believe, then you can't like use it to get even more. So that's important. Let's keep going. So interface, like you get the drill, but let's look at some new routes. and then we'll talk about tokens. So I honestly just don't remember off the top of my head what all the new routes are. We have actually split them out physically this year. That's good. That makes it really easy. But this looks like there's a lot, but to be honest, it's not that many. How would I put it? The thing with iteration 2 that was really hard was that you kind of had to go from something that was really small in iteration 1, and you had to blow it out to something really big with all these different parts and messages and pagination and all these other crazy things. But for iteration 3, whilst there's new features and things to implement, they're all quite separate, which actually will make your life easier as a group, because as a group you can divide and conquer really easily. Like you can all kind of just work on these separately, and that's really, really good in terms of your productivity. And usually with iteration 3, if you're a group for iteration 3 that really gets started this week, you can honestly get a lot of the coding done pretty quickly. But the main things here are that there's some admin permission settings that you can change. There's some, I don't know, there's some stats that you provide to the front end. There's the ability to upload a photo for a user. There's the resetting of a password. There's the running of a stand-up. There's the ability to send a message or DM at a later date. There's the ability to pin and unpin, and there's the ability to react and unreact. And there's the ability to share a message, and the ability to search, and the ability to get notifications. Now, again, I'm not trying to point out that this is like no work. This is probably like, I always describe iteration 3, and this will make sense, I guess, for the local students, but it kind of reminds me of like year 12 in high school. It's like year 12 was harder than year 11, but year 11 was a much bigger jump from year 10 than 11 was to 12. So if you kind of think of like, iteration 1 is like year 10, iteration 2 is like year 11, where it's like the world just come and hits you in the face. And then iteration 3 is like year 12, which is, things are quite hard and serious, but you're already in a kind of rhythm. That's usually the experience we see with students in this one. So that's something to keep in mind. Now, just want to talk about some really important fundamental differences in this iteration. So email format, testing, pagination, they're all kind of the same. Permissions is something that's very relevant in this iteration. User sessions, from the previous iteration. Working with the front end was in the previous iteration. Couple of points here. So, and this is just the last of section 6. And I'm only going to talk about some of it here. There's a lot of stuff to read that's very helpful. This isn't long necessarily because we want you to like, oh my god, there's so much stuff to do. This is kind of long because there's a lot of explanation. So when we first wrote the project, these sections used to be quite short, but then we made them longer just to help out. So it's actually quite it's long because we have lots of helpful information there. So now when we look here, firstly, for iteration 3, instead of just returning an error object that says error, we will actually get you to for iteration 3 to be returning HTTP status errors. So if you remember back in the Flask lecture and stuff, we actually talked a lot about how there's like 400 error. We talked about 400, 403 errors and stuff like this. So for this iteration, instead of returning error, you'll actually be throwing an exception. And that's actually quite useful because it's not a massive shift. It's basically like now the errors aren't different. So from the previous iteration, it's not like the errors are new errors or anything. A lot of them are just recycled from the previous iteration for the old routes. But it's more like instead of returning an object, you're going to be throwing an error. And there's instructions here about how to throw that error. One particularly interesting thing is that what we decided to do when rewriting the course was to demonstrate to you the power of NPM. We actually wrote a library designed for the 1531 project that would help you manage these errors. It would help you essentially throw them and get the right result. And we actually went and wrote this and published it up to NPM. and we wrote it in TypeScript. And you can actually like, there's no documentation here, which isn't very good. But essentially, it's like a tiny piece of code. It's like a single file of code that myself and the tutors wrote, and I think it's sitting right here. Nope, it's inside the source folder. It's this one file, and when you actually include this in your project, which I can't remember if we included it for you, but there's instructions anyway, it actually is the code that runs that helps convert your errors that you throw to something usable for the front end. So it is a 1531 specific thing, and the reason we did this was to basically just show you how powerful in this world of software engineering that like package managers and libraries are. So that like we managed to actually go and publish something. 334 people downloaded it. Whoa. It's probably because we included it already, I guess. And yeah, and what happens is we already found an error with it, I think earlier in the term, and we just pushed to GitHub a fix, and we published it on NPM. It takes all of 20 seconds. Maybe we can talk about that in week 10 or something if we really want to. But yeah, that was super fun and useful. So that's something to keep an eye out for. Another important part of iteration 3 is securing your sessions. So this one is super interesting because in iteration 1, we just had you return a user ID. In iteration 2, we had you return a session. And a session contained a user ID, but they were all still exposed to the same problem, which was what happens if someone puts in a fake session? It's very hackable, basically. Like someone, those of you who are quite switched on probably noticed that it's a little bit strange that someone could just go and change this information and then pretend to be someone else. So as part of iteration 3, we're actually going to change how we deal with tokens. Thankfully, if you've done your code well, this should just be like a change you only need to make in one spot. We actually talk about this a lot at the start of week 9. It's actually the first lecture next week. And that's where I can go and explain it. We can go into a lot of depth with this stuff. It's super interesting and it's not too hard. I would encourage all group members to get engaged with it. But here's the important thing. Because we don't talk about this until next week, in week 9, some groups might struggle to start it because you don't understand what you're doing. That's okay. Week 9's not that late. Like, it's still a week and a half until it's due, and it's quite a minor change. So don't stress that there's something you have to do in the spec that we still have to have a lecture on. There's plenty of work to do in the meantime, don't worry. But what I would say is that what you'll notice in this iteration is that it does say a bunch of stuff about like the tokens have been removed from the query parameters and stuff. So anything to do with the token changes, I would say just leave that alone till next Monday if you're not feeling confident, and we can talk about it. Most of the instructions are actually like here, and the lecture slides are pretty good. So if you're really, really keen bean, and we saw in iteration 2, most of you aren't keen beans, most of you aren't rushing to get things done. The point I'm just trying to make here is that there's the token lecture next week, or like the auth lecture, which covers this in a bit more detail. You are more than welcome to not worry about this. You don't need to do this to start this iteration. You can absolutely come back to this later. So you can come back to that next week. There's a few other things here in terms of instructions around notifications, tagging, analytics, React, stand-ups, profile image and image uploads. They're all written out to be quite helpful and explanatory. Some parts will be harder than others. Some parts will be easier than others. It really depends on what part you're dealing with. So just keep an eye on that. And besides that, demonstration, contributions, blah blah blah. The rest of the spec is exactly the same as previously. So that's all of that. We'll keep talking about this, tomorrow, next Monday. Should all be totally fine and pretty fun. There is a ton to do. Like, it's all relative. Sorry. There can be a ton to do if you leave it late. So like my sincere request to every group is don't let this one slip away from you. it's not like iteration 2 where you have to go from year 10 to year 11 and think about what a server is and think about what TypeScript is and deal with linting. All of that's the same. You actually just have more routes to do in this iteration and a couple of minor refactors, such as the auth stuff. I should write that here. Auth token, such as the auth stuff and a whole bunch of routes, new routes. And coverage isn't even like a thing to do. That's just that you're going to get a score and look at your tests and go, huh, that's interesting. So yeah. Now, I'm going to jump back to the slides in a second and keep talking about a few particular parts of iteration. Of iteration 3. But before I do that, I just want to ask, does anyone have any questions? I'll just give you like 10, 20 seconds to ask questions. Just while you do that, I'm just going to fix something. My computer fan's being quite loud. Okay, so Nigel's asked a really good question, which is, what group are you in, Nigel? I can probably look that up, but like, what group are you currently in? So like Nigel has said, my group doesn't have iteration 3 yet. Should we expect it to come in a day or two? Nigel's in H13 eggs. Okay, so let me just go and look up your group, Nigel. So, what groups we got? Oh, groups slash H13B eggs. So you should see that in the merge requests, we have actually created so there's a couple things. One is we've created a feedback merge request, which your tutor will explain to you later on. This is basically something we've made where your tutor can actually go through and like leave comments. So we've kind of created this like fake merge request so your tutor can come and leave comments in your code if they want to. It's not a requirement that they do. It's more just like we've given them the option. But you'll see here there is a new merge request here that you have to merge in. And just like the last iteration, you can see that there's merge conflicts. These merge conflicts are somewhat unpreventable to some extent because of how everyone does things differently. And typically, again, some groups will find this really, really easy to merge in. Some groups will have to spend a bit more time. But what I've also done is, and thanks to my tutors for this, I've gone and in the ed, I've pinned the iteration merging post up again. So, and I've changed the names and stuff around. So you can basically just go and follow this to merge it in if you haven't already, like if you didn't have any trouble with that previously. So that's just something to keep an eye on. But yeah, that's it. It's there. It's just, you have to look for it. It's a merge request and you might have to deal with the commits. Cool. So the next part of this iteration 3 lecture, which will go on for a little bit and then we'll take a break at the end, is, and tomorrow should be a short lecture, I believe. What do we have tomorrow? Use cases and validation. Yeah, tomorrow will be a short lecture. Okay, so let's have a look at our code. Which I think I have to go to code 2 because I had those environment problems. So what do we got? We go back to our lecture slides. We got this. We got a few things: stand-ups, images, storing images for the profile images, sending emails for the password reset. These are like 3 features for iteration 3 that I think are worth just spending a little bit of time giving you some help to get started. So the first one being stand-ups. The thing about the stand-up route, if you go and read it, is it's very straightforward. The idea is very simple. You go into a channel, like a channel on your project, and you type in /standup start or something like this. I can't remember exactly. I think it's like this, something like stand-up start. And what happens is once you enter that, everyone in your for a certain amount of time, everyone in your team everyone in that chat has a window where if they type a message into the chat in that time, I am working on X. So like this is Hayden. And then say, Alex comes along and says, I am working on Y. As they're sending these messages, they don't appear in the new message list. But once a time is up, like a 15-minute time is up, what happens is they all get condensed into a single message and sent back to the front end. So it's kind of like it's like a buffering thing. It's like you say I want to start a stand up, and then the stand up starts, and all the messages come in and are captured quietly, and then at the end of the stand up they all get pre-populated. They all get populated back into a single message. The spec is quite kind of clear on this in a bit more detail, but the point is that to do stuff like this, you often need to deal with timing, and you start to get into the beginning of an area we avoid in this course, which is asynchronicity in programming, which is the idea of multiple things happening at the same time. Because if you start a stand-up, your server also needs to keep operating. It needs to keep receiving messages in other channels and creating channels and registering users and everything else. And it can't just stop and wait for 15 minutes, because that's kind of like your basic C style approach to things. If you had to start a stand-up in C, you would enter like a while loop and then just loop forever inside that while loop listening for input, but it will completely stop the program from doing other things. So we have a really, really simple piece of code here, which we can look at together. Just going to get this up. Where basically it's called 8.4 Timeout. And what it shows us is actually how to deal with the basics of asynchronicity in JavaScript. And how this works here is that I start my program and I say that I have a variable called time, which is equal to 3. Then I console log and says I'm going to start my stand-up timer for time seconds, 3 seconds. And then I've got a function here called finish stand-up, and I want this function to, which just console log stand-up is now over, and I want this function to be called after 3 seconds. Now again, the kind of simple way that you might do this is typically saying something, like while, you could do this a bunch of ways. You could, let's say I know that every time you do a while loop takes 1 millisecond, which it doesn't, but let's, let I equal 0 while I is less than 30,000 or 3,000, as in, a loop is a millisecond, so I do 3,000s, I plus plus do nothing, and then at the end of it call finish stand up, like that, That's like a really old school way of dealing with it. But JavaScript has because JavaScript's partly event-driven, which is one benefit it has as a language, is that it deals with this stuff really well. There's actually this function built into JavaScript. You don't have to write this, it's just part of JavaScript called setTimeout. And what setTimeout does, is it takes a function to call. A function is a first-class function, right? And it takes in a time in milliseconds, which in this case is just 3 times 1,000, which is 3,000 milliseconds, which is 3 seconds. And what it does is when you call this function, it immediately starts a timer on the computer, counting up to 3 seconds. And as soon as that 3 seconds is up, it calls that function. And we can actually see this program in action here if I simply run, npm run ts node on source/8.4 timeout. You'll see that it will print starting, then it'll 2, 3, and then it's over, right? And I could increase this from 3 seconds to 6 seconds. 3, 4, 5, 6, like that. So this is kind of how you can deal with these things. Some groups might have already discovered this when they were doing like the saving, the persistent stuff, because you might say, save your code every 1 second, because there's actually another function in JavaScript which isn't just set timeout. This isn't very useful for the stand-up stuff, but it is useful for other things potentially, where if I run this, instead of set timeout, set interval has it doing it indefinitely. So now it will just keep printing it out every 3 seconds. Obviously the text here makes no sense, but I can't really give too many more hints without explicitly, telling you how it works, like telling you what to code, which is not really my job. But that's a starting point. So if you want to play around with stand-ups, go play around with that sample piece of code. It shouldn't actually be too hard. In fact, there's like a list of 30 things that are better using JavaScript in this course than Python, and a list of like 15, 20 things that are worse. And this is one of the things that are better. JavaScript is kind of designed to deal with these things very elegantly. So that part is very exciting. So back to this. That was a really simple one. Stand-ups, yay. The next one is storing images. So another part of the spec is that you want users to be able to upload profile pictures of themselves, right? Makes sense. You can do this on Teams, Slack, Discord, all these things. And if you want to upload profile pictures of yourself, what that means is that a user has to give you an image, or in our case, a URL to an image. You have to, on your server, take that URL, download that image from the internet, store it on your server, and then provide it back to a user on another route. So again, I'm not going to tell you exactly what to do to solve the problem, because that's the point of the assessment, but I can show you a few key parts here that will point you in the right direction. The very first thing is that if you have image files on your computer / server, you can actually serve them really easily like this. So I've got this little sample piece of code here, 8.4 image serve, and it looks kind of like an Express server. It's got the import, the app, the port, and the listen, but it doesn't have any get or post routes. Now it could. It just has this one extra line here, and you could go and take this line and you could add it to your own project. And what this line does is it says, hey, if anyone accesses /static / something, for instance, HTTP localhost 3001 /static /hi.png, what I want you to do is to go look for that file, hi.png, inside a folder called static. Now there's a lot of static going on here, so let me just change some of these around to be clearer. I'm going to call this one apple, and I'm going to call this one banana. And what this is saying is that if someone tries to load localhost /apple /hi.png, go look inside the banana folder for that file. And let's try it with something simpler like hi.txt. So now what I'm going to do is I'm going to go and start this server. Now naturally the problem right now is that there is no banana folder here. In fact, I actually need to check. I need to make a banana folder. I think it needs to be here. And then inside that banana folder, I'm going to go and add my static file, hi.txt. Smiley face, right? So now that I've got that folder with my files in it and I go run my server, in theory, all I have to do, in theory, I probably have missed something here, is if I just go and open up Chromium and I go to localhost 3001 /apple /hi.txt, there's my file. So this is cool because, again, this is just something really helpful that Express does. There's other ways to do this without these things that are just a bit more cumbersome. But again, it's saying anyone who accesses /apple should get a file they're looking for inside of the banana folder. Now, this is really helpful. And again, this is one thing Express is quite good and clear at, because if you're dealing with people's profile pictures, you can store all of people's profile pictures in a folder somewhere and just tell Express that there's a folder called /profilepics to go and look for them in. Again, this will make more sense as you go through the spec. I'm talking about iteration 3 quite early. I know most of you haven't even read it, and I know that many of you will kind of come back and click on this recording, and that's totally fine. But or hopefully you don't, because you just kind of remember some of these things, like Hayden broadly saying that, oh, I just need to go and look at these two pieces of code. So you go and look up this one. And then the second one, which is important, is the collecting and storing of an image. So I just kind of did this backwards. I showed you how to, once you've stored an image, serve it to someone. So like create a URL that someone can access. But a more interesting thing is how do you actually collect and store that image? So I've got another file here, which is 8.4 pull image. And what pull image is it's essentially a file that contains a request library, which is how you can make like web requests, like load something on the internet, on the web. I've imported file system, fs from file system. And then what I've done is I've made a request call, which is just a get request. For this particular URL, I don't remember what this is. It's either going to be very boring or very stupid. Yep, the latter. And what that's saying is go to that URL, get that for me here. And you're kind of probably familiar with this request response notation, but in this case, response dot body, get body here is actually saying get me the contents of the image, which is just a whole bunch of binary. It's just an image. It's just data. And then I grab the body from that image, and then I write it to a file. So I actually go and save that to a file. But I could do you one better. When I run this command, instead of saving it to test.jpg, I could actually save it to banana/test.jpg. And that'll put it inside my static folder. And in fact, I'm going to call it giraffe.jpg. So now, when I go and run this particular piece of code, pull image, it will go and pull that image from the internet, and it will save it in the folder banana. And in fact, when I look at banana, you can see there's now a giraffe there. So if I go and load up my old server, my image serve, now that I've pulled it and stored it, if someone was to come here and load up /banana/giraffe.jpg, my server is now serving them that file. I'm on my local computer, so that's not going to work. I need to be on VLab. /apple actually, not banana. There's the giraffe. Now remember, it's /apple because the route says if someone accesses /apple, go to the folder banana. Now typically everyone just calls these two things static and static. The only reason I changed it was so that you could kind of understand the difference between the two. But that's it. Again, haven't told you exactly the exact thing to write. That would be stupid for that profile picture upload. But if you can apply these two pieces of code together, you're most of the way there. I thought about how funny it would be to like pretend this was like a really big bottle. Just like pull this out of the frame and drink it with a straw so it looks really big. Cool. So, great. That's that part. The third part is sending of emails. Now, this one is actually this one is one of the harder ones in the sense that we don't want to give you a huge helpful tip with this because that takes away some of the challenge. But what we can say is that sending an email is not a programming activity. It's not that you have to go and write some code to solve problems and send an email. Sending email is actually just something that you need to kind of look around the internet and find a service that works well. Now, historically, one of the easiest ways that you can do this, we've seen this happen, is just if your team signs up for like a fake Gmail account and you go and like if you Google, I think I've written it here, right? All you need is something that allows you to send emails over SMTP. Again, this is one of the harder parts of the project. It's not hard in the sense that it's like intellectually challenging. It's more just like independent learning. If you Google something, send emails over SMTP, there'll be a service like Gmail that'll let you do it. You can do it with Gmail. And then separately, if you Google like Node.js send email, you can just like, you can Google this stuff. Like when we first wrote the course and I was demoing this, I Googled it for like 5 minutes, found an answer, tried it out, worked fine, so just spend the time. But sending emails, the point is that you're looking for libraries and services to do this for you. You're not trying to like code some while loop that sends packets of data or anything crazy like that. Now, the last few things before we take a short break is quickly double check. Give me a second. So one thing we haven't talked about, we kind of mentioned this in week 5. In week 5, we talked about express and we talked about exceptions, right? There was questions around how do exceptions work with our server, and I said, I'll come and talk to you about that in week 8. And here we are. Welcome to week 8. So this is a very simple express server that we have. Now, most of this should be very familiar to you because it looks the same as other stuff you've done. The one difference here is that instead of returning error, on line 8 here, we throw a new error. Now, this is not the right way to do it. I'm simply demonstrating to you the wrong way to do it. So normal server, but instead of returning an error, because right now, like, and you can put this in an if statement, right? Like, you know, if true, what you're doing currently is you are returning error. Yep, easy. But what we want you to do instead for this iteration is instead of returning that, we want you to throw something. We want you to throw an exception. Now, if I come here and I try and run this server, 8.1 express, I don't know why it's 8. Actually, I don't know why those files are 8.4. They should be 8.1. I think I must have just forgotten to change them. Let me make a note of that. They'll probably be 8.1 by the time you go and look at them, if you ever look at the slides. But for like people watching the recording. So now it's like I got 8.1 express error 1.ts. Now this server will run fine. You know, if we look at the code, it's going to run perfectly fine. But let's actually see what happens when I try and access stuff. So when I access localhost 3001/go error, was it go error? Yeah. What I actually get here is it says error, oh no. And whilst it has actually printed out my error, it's printed out a whole bunch of other stuff. And the reason for this is because by default, this is a little bit complicated to understand. When you throw an error on an express server, the receiver and the server itself actually thinks that the server failed, which makes sense because we threw an error. We said that, hey, there's a problem, and we just threw it. We just threw an exception, didn't deal with it. And therefore, everyone's like, oh, the server made a mistake. The server had a problem, you know, whoops. But what happens if it's the user making an error? What happens if their password's not long enough? What happens if the email address they entered isn't valid? We can't just throw an error saying email address invalid because we'll get the wrong error code. So how iteration 3 is set up, that line is wrong there too. That's good. I should make a note of that as well. What slide's that? 7.2. It should be this line here. That's the one that's meant to be highlighted. So what we actually do instead is something a little bit more involved. And the main things that we need to add here are we need to include these two input lines. I'm just going to copy them. Oops. Sorry. Why is it so annoying? Yeah, we need to include these two lines here up the top. The first one is the actual errors to throw, and the second one is some express stuff that 1531 wrote to help you catch them and deal with them. You then, instead of throwing error, which is just like a generic error, instead of throwing a new error, you actually just throw an HTTP error, which is one of the things you imported here. And an HTTP error doesn't just take the text, but it also takes in a status code, which we tell you in the spec, and is typically either 400 or 403. So very, very straightforward there. And then the last thing you have to do, as per the instructions, are you have to copy this line here and put this line, and this is really important, you need to put this line below all of your routes. It should sit just above the listen. Don't put it at the top. Everything will break. Sincerely, it will all break. So we put that at the bottom. I've got a copy there. And now when we run this code, we can try it out. Now when we run this code, what happens is that instead of getting, and you can actually see it here, if I come back here locally, what you can actually see, I don't know if it will come up, but it didn't, that's okay. What you'll see here is that when I refresh this page now, the server is actually designed to throw a proper 400 error here. You can see it says 400. I've just screwed it up. One sec. Yeah, see their status 400, bad request. So what that tells the front end that's reading this is that, hey, you gave me bad input. Here's the error back in a nice format for you. This is the error used by the front end. And, you know, that's really helpful. What this means for your tests, which is something that's quite relevant, is that I'm sure your tests currently, and this is where things actually get like a little bit tricky to understand. There's a bunch of stuff, like if you're writing jest tests to catch exceptions, then there's certain code that we looked at in week 5 that you can use for that. But you're not writing jest tests to catch exceptions because like you have your server over here and you have your tests over here, and the exceptions are being thrown in the server and they are being caught in the server. And if they're caught, the server just, instead of returning something successful, it now just returns you like a 400 or 403 error. So the reason this is important is because you don't actually have to catch exceptions in your tests. What changes is that when something is an error, instead of you checking, should this return an object that says error, error, what you're actually going to check now is the status code of the response a 400 or 403, right? And you can tell this from the spec. It's all just written in the spec here. Like, you know, when a channel ID does not refer to a valid channel, instead of checking as the object error, error, you actually just check if the status is 400, and you can easily do that. Like, what's the library we get you to use? Is it sync request? I'm honestly so forgetful. It is sync request, right? So it's like, if we go look at the sync request library, sync request status code. I just can't remember this off the top of my head. Maybe it's written in the library. Someone probably knows because someone's already probably done it. See if they tell me in the chat. But if you look at the sync request library, it's probably just written here somewhere. Status, there we go, status code. It's right, written in, read the page, Hayden. So you can see that the response object doesn't just give you a body, but it gives you a status code as well. And you can just check if that's a 400 or 403. That's it. It's just, that's the difference. And this is something slightly closer to what you would actually do in reality, because typically when you're checking if servers have errors, you would be checking the status code, not the value of what it returns as much. So that's that particular thing there. So that's all quite well documented in the lecture slides. Oh, what's that? Wait a minute. I'm so confused. Okay. Perfect. Okay. Now the next one is express with coverage. We kind of talked about this a little bit. And we've updated all this in your project for you. To get coverage working with jest, typically you only need to add the -- coverage command that we did last week in the lectures. But to get it working with the express stuff, you need to do a few extra things again that we have done for you. Let me just go and get the actual project up here. What we've done is we've actually added some stuff to your, at least we should have. I'm pretty sure. I should double check that. I need to check with the tutor what happened there. But basically, we've added some stuff to your project. We've also added a new library. And as we talked about before too, and as is written in the spec, you now have this command here, ts node coverage, which you run instead of npm start. So instead of running npm start, you run npm run ts node coverage to start your server. That's really all there is to that. It's all been added to your code. You know, there's really not a lot to do there, not a lot of new information. It's all very straightforward. We can go and run this here, I think. Hopefully it doesn't break. This is the first time we've done something like this, so let me just make sure nothing's changed. Sometimes we've been kind of fixing a lot in the course as we go, so let's try this out. So I've got two files here to test with today just before the break, which is 8.1 express error 2 and 8.1 express error 2.test. So let's imagine that this is your project for a minute, where you have this is your server, and then .tests are your tests. So the first thing you would do is you would go npm run ts node coverage, except I might have to manually configure these. Oh god, one sec. I might, like, you won't have to do this, but I've got all these different files here. So npm test node coverage ts node. Let's try that out. So let's say I run npm ts node coverage on source /8.1 express error 2. So that's my server. Oops, needs to be .ts. So I'm running my server. It's just a different command to use. Instead of ts node, it's just ts node coverage. And then separately to that, in the same terminal, sorry, in a different terminal, I will just run npm run jest with coverage on source /8.1 express error 2 dot. Is that the right file? Oops, sorry, I need to be in env2. npm run jest coverage source 8.1 express error 2 dot test. I think it missed my command. Whoopsie. There's this thing I haven't quite figured out with npm, where what it does is if you put the dashes in the npm run command, it just kind of ignores it. I'm not really sure why. So in this case, I'm just gonna again, you don't have to do this locally for you, but I'm just gonna do it here for me. I can probably get away with it by adding coverage here. These are again just obscure things associated with me running it. But let me try this, see if this works now. Yep, that seems to work. Cool. Now I'm getting the 0 error that people are getting in the forum, which is probably because I've got a whole bunch of old outdated stuff. So I need to go and double check that. But if you actually have a look at the code here, it's very straightforward. We have a go error function. We have a hello function. Here we call the hello function, which should in theory go and actually run these lines of code here. But in this case, I'm getting 0, but I'll go and double check that. I think we've changed a bunch of things on this since the lecture code was written, so let me come back on that one. But point is, that's the exact thing you do. Again, you just have to run that command, jest. It's all kind of written and documented here. If there are slight touches we have to do to help with particular groups, because particular groups have problems, we'll communicate those, we'll update the spec. But that really is gist. You just run it like that. I'm just reading it. Yeah, sick. And just like we saw with exceptions in week, just like we saw with coverage last week, checking this is really easy because you will actually have also this coverage folder, which inside of it has the lcov report, which inside of it has, the index.html, which you can just open up in a browser, right? It's the exact same thing. It's just in this case here, it didn't read any files because it's being a little bit of a poo-poo. So I don't want to waste your time right now looking at that. I'll go look at that after. But that's the gist. Anything small, like if once I remember what was missing from my code, if it's something that is specific to the lecture code, we'll just fix it and don't worry about it. If it's something we need to fix with the project code, we'll either just push a new merge request tonight, or if it's something weird, we'll post on the forum. But same process, exact same thing. So really easy. I just have very old code here, so I don't trust it. Like, I wrote this all before the term, and a few things have changed, and I probably just missed some updates. Now, that pretty much sums everything up for iteration 3, which gets us onto the feedback slide. Thank you for leaving some feedback. Do we have any questions before we wrap up, take a break, and then talk about requirements quickly? Just about iteration 3 or any of the things we've talked about? it's a iteration 3 is what I described to you as it's a lot of a little, like it really is. So please get started. If you're a group, you know, have your class this week, set some plans, just get some stuff done this week. By this point, you should all really be comfortable enough to go and do some things and test some things out. Okay, I'm just gonna see if here we go. All right, well, no questions. Great. Good luck. And as I said, our staff and stuff are totally here to help. Fu Yong Ho says, if we haven't finished iteration 2, should we not merge iteration 3 until we're done? No, I don't think you need to wait. As I said, iteration 3 is really an extension of iteration 2. Iteration 0 to 1, we added NPM. Iteration 1 to 2, we added TypeScript and ESLint. Iteration 2 to 3, we didn't really add anything. Sure, we're asking you to do coverage and exceptions, but they're not really like new whole things. They're just like little tweaks. So no, merge in iteration 3 and just go for gold. You got 3 weeks, just under 3 weeks, just like get it done. Yeah, but... Oh yes, to Hello Clayton's point, iteration 3 does remove the iteration 2 spec, but it only removes the the upper section part. It doesn't remove the actual routes and stuff, which is most of what groups are looking at. So yeah, it does remove this bit here, but for many groups you kind of get that part. You know, you're not really like trying to figure that out. But all the iteration 2 data types and things here are totally the same. So that part's all the same. So that's very manageable. But yep, get started. Again, rely on your tutor, rely on the staff. We're here to help. 2.5 weeks and then we're done. And again, if you're feeling a little bit overwhelmed by everything, I'd just like to remind you all the good news, which is that once iteration 3 is done and you submit Lab 8, you have done 80% of this course. We have the smallest exam in 1531 history. When I think I took this course originally, the project was half the weight and the exam was 50%, and we've slowly been notching it down. So I'm very excited for you that you can have a low pressure exam. So if nothing else, that's a silver lining of feeling like you've got a lot to do, is that it all pays off with a much less stressful exam period. So anyway, let's take a break, and please leave some feedback on this lecture. Pause the video, all of that, follow the link. Thank you very much.